Hey, good morning. So, I've been working on this NFL betting project. I made a lot of really good progress on it about 6 months ago, but then I got busy with work and school and life, and I didn't finish. I have the last thing I did back in either December or January is I got a successful technique working. And this stream, I'm going to organize everything so that I can um, kind of move forward from here. The goal is by the start of the NFL season, I want to have at least a dozen different strategies that I can be employing. And I'm kind of using this as a motivation to get myself to work, because if other people are watching, then I know that I work hard. So, there's in spread history data was the directory. Now let's look in here. Now let's go to our Trello board and see what we have left to do. Determine one or few best performing classifiers and hone tweak results. Find new objective to optimize for doing. Yeah, I think I'm kind of lost on here. So we're going to have to go through here and clean up the Trello board. There's a lot of stuff on here. Because I haven't worked on this for 6 months. So I have to delete everything that I don't know what it means. You know what? Let's just delete all of these. Delete all, delete all, delete all. Archive all cards in this list. Archive all. Okay. This one I'm also going to archive. I don't even know. Mess around with classifier parameters to get positive results for all seasons. Oh, I already did that. Done on last live stream from December. Save out of here, move that to done. Different optimization techniques. Let's just fucking archive this. Okay. Now what we want to do is formalize put all functions into a functions file. Okay, so I'm going to put all functions into a functions file, and we need to separate the functions based on if they're based on a strategy. Let's see. Oh man, I don't even know where that PowerPoint went. Let's go find this project. PowerPoint, maybe in YouTube. Personal stuff. YouTube. No. Okay. It's in PowerPoint somewhere. I don't want to share my work stuff on accident, but I can exit out immediately if I have to. Analyses. Yes, this is the right one. I knew it. Okay, so what is this? General spread versus spread swing versus performance against spread. Did I not document the? Great, this is the one. Yeah, the Gaussian process classifier. So So I documented it here. This is kind of the regions the classifier picks. One of those is homes for wins for home. The other is like wins for away. I don't remember which. Implemented nearest neighbors classifier numbers are returns from 2008 to 2021, using all previous seasons as training data with classification threshold of 0.95. Oh, so that's not positive for all seasons, but I guess I tweaked. Classifier works when using 10 nearest neighbors in 8 to 12 training years. Oh, so it's n nearest neighbors. Gaussian process classifier returns all positive. Okay. So we want the Gaussian process classifier. Oh, and I guess I already moved on to a second analysis. So I'm already on the second analysis. This one's totally done. Let's go look at our code. And more things to exit out of for work. Get out of there. Oops. No. Don't save. Save that. Okay. Now let's go to our files. Hi, buddy. Buddy's here. Good morning. Buddy wants to go on a WALK. Ubuntu home Platchap. Spread history data. Where is that? Oh. Okay. Analysis 1, trend whatever. Oh, I guess I already broke it up into its own thing. So let's go look at this and figure out what is going on here. Optimize classifier equals true. And what's the last thing we did on here? Optimize classifier equals 1. So if I run this, it should just pop up with the classifier. Python 3 analysis 1.py. 1.py. Oh, some weird Python thing. Now I need to do Python 3.8 analysis 1.py. Alright, come on. Nothing's happening. Maybe it's taking a while? Oh, very good. Okay, well that's something. That's on some number of years. I forgot this takes a while. So I have analysis 1. I don't even know. I'm gonna archive that already. Work on analysis 2. So I guess for analysis 1, I just need to make a video for that, and that will be finalized. For analysis 2, let's go see what that looks like. Get last week's spread swing. Wow, this is actually a lot of code. Okay. Oh, my water boiled. Need more coffee. Yowza. Hold me on the shaggy. Ask that the Drazen All right, got more coffee. So, did anything pop up yet, or is that still running? I guess. No, is that negative? I don't know. It just keeps spitting out the same thing. I don't really know. I hope I didn't lose money. Plot. Oh, this is analysis 2. So if we go back to analysis 1, wow, this is long gone. I guess I finished this a while ago. I guess I totally forgot where I was at. I should have just kept working every day and making good progress. I have to pull up that YouTube window so I don't miss comments. All right. So in analysis 1, we have to figure out what the optimize all does. Optimize classifier is equal to true. Bunch of different thresholds, years to look back, results for threshold and thresholds. Oh man, that's gonna take a really long time. Okay. I'm just gonna forget about that now, and then if the output is different from what we have in the PowerPoint, then do something about it. If output from code is different from PowerPoint, then fix it. Okay, now we're into analysis 2. Test plot last n weeks spread performance. So strategy 2, I kind of forget what we're working on here. We're using greater than or equal to 7 training years. It returns all positive. Why does it keep printing out the same number? What are those two numbers it's printing? Print A. Test previous spread swings. Oh, this is analysis 2. So back here, what's printing? Two numbers. Print profit. Print region type. Print is total return profit. I don't really know. I'm just gonna wait for the output. Okay. Analysis 2. That's not what I want. Analysis 2. Point differential of current game versus home and away. Performance against spread last game. Home performance against spread in previous game. Away performance against spread. Home performance against spread in previous game minus away performance against spread. Y-axis is point differential from 2018 data. No turn to parent. Answers question: does last game's performance against spread contain any predictive information for how this game will go? Performance against spread this game, home minus away, versus performance against spread last game played. Okay, so this is just, I'm pattern searching, I forgot. So if we look at the performance against the spread, if we look at the point differential of the current game as a function of the performance against the spread, I don't see any obvious trends. Same thing goes here. There's no obvious trends. Now, we might be able to get something like, we might have to add in more information, like if we could get something about like the team's power ranking or something like that. Maybe that will do it for us. So, this game, swing and spread this game versus performance and spread. Oh, so now we're looking at swing and spread and performance against spread. Spread swing versus performance against spread last 2 games, 2007. Swing and spread open to close this game versus. There's not. Do same analysis on performing with the spread but with the total data. Okay, so here, let's go up here. Now I'm gonna insert a new slide, title slide, delete, new slide, title slide. Switch those two. Analysis 1. Change in each team's odds to predict the game winner. Changing each team's odds. Predict the game winner as a function of the change in odds for each team. Okay. So that's all for analysis 1. Now, new slide, title slide, analysis 2. These should be their own color. So analysis 1. How do we change the color? Designer. No, I don't like that. That's stupid. How do you just change the color? Section, reset, copy, format painter, layout, format background. Color is red. Alright, change this color to white. White. Maybe make this a little darker. Predicting point spread as a function of each team's previous performances against the spread. Okay, same thing. Okay, cool. So we have analysis 1, analysis 2, swing and spread open to close this game versus swing and spread previous games. I don't really know what to make of this. Well, how many data points are there? So that's the 2018 season. We should probably just do all seasons, right? Maybe we could see a pattern if we use data from all seasons. And maybe if we colored them differently. Okay, so if we look at all seasons, now let's plot all seasons from scatter plot all seasons spread data with diff color coding for each season, and then edit labels, high priority. If output from code is different from PowerPoint, then fix it. Also high priority, work on analysis 2, high priority, and that's what I'm up to right now. Scatter all seasons, spread data with different color coding for each season. And then I want to organize all of this into a Jupyter notebook. So that it's easily documentable and repeatable. And then also get new data, by data, question mark, for more recent seasons. And that's not as high priority. Okay. So we've done a lot of stuff already. All right, so now we're trying to plot everything. Get last week's game, get last week's spread swing, get performance against spread. Is this done running yet? Nope. Get performance against spread. Okay. That's not the results we were hoping for or expecting. Let's go open this up. New slide. Long pause in work. How to repeat last slide. After not working for a long time, I don't know. It's down a little, it's too high. I don't know. After not working for a long time, I don't know how to replicate the results on the previous slide. Hence the importance of Jupyter. After not working for a long time, what? Oh my gosh, that's taking forever. That's gonna be hours. Running analysis 1, so let's go back here. What's that thing we're running? Optimize classifier. Running optimize classifier returns okay. Now let's go look at what that data looks like. Copy, paste that in there. Okay, so y is the same amount being returned every year. And then here, troubleshoot analysis 1 classifier. And that is high priority. Move that up to there. Scatter all season spread data with a different color for each season. So spread data. Get analysis, plot analysis. Oh, I'm on 1. So test, plot, last n week spread performance. Test, get previous spread swings. Test performance against spread. Test single season. Test single season equals true. For week and weeks, get data of 2018 week for spread and spreads. Okay, so let's just do in here for test all seasons. Test single season. Test all seasons. It's equal to 1. Change that one to 0. Now test single season equals true if test all seasons is true. Then what we want to do is the same thing as here. Okay, test all seasons. Spread swing. Okay, so we have all seasons here. We're just doing 2018. For all spreads equals that. So let's just go up there for season. Seasons is equal to what year are the seasons? 2007, I think, is when it starts. Let's go open it up. Oh, I'm gonna go in there. Ubuntu, spread history data, home, spread history data. Okay, now data 2007 through 2021. Okay, seasons 2007 to 2021. What's that look like? Cool. So test all seasons equals np.arange 2007 2022 dot toList. Cool. Now don't have numpy, so import numpy. Now we can run the second analysis. Spread history data, Python 3.8. It's not defined, I just, as np. Now I hope this doesn't take too long. Oh crap, it's gonna take forever. Alright, well we could go work on something else. What is that? What's it printing? What's it printing? Test get last week's season. Test all seasons. Oh crap, that's not the right thing. End it. I don't know. Why would it be looking for week -1? But that might just be because the exception. Whatever, I'm just gonna do it right here. So for season and seasons, block indent, all of that stuff. plt.scatter, and then label is equal to season. Are there enough colors? Tableau colors and matplotlib. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 21. 15 seasons. So we need 15 colors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 colors. Regular. Python named colors in matplotlib. Forget the names of the colors. Oh man, okay. Let's just put them in here. It's the ones that will work. So colors that will work. We need 15 colors. Okay. So first we have black, which works obviously. Red. We can also have maroon. Red. Orange. forest green. Okay. What else looks good? Blue. I'll just do all the straight up ones. Blue. Magenta. Alright, that's 1, 2, 3, 4, 5, 6. Now we just need 9 more. So now what can we go with? We have red. Fire brick maroon will obviously work. Light salmon might work. Saddle brown will obviously work. Might be hard to differentiate. Yeah, let's do chocolate. 1, 2, 3, 4, 5, 6, 7, 8. And then we got chocolate node, goldenrod. Works. What's that say? Cade blue. Dodger blue. Deep sky blue will work. Cyan will work. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Indigo and medium orchid are different enough. Medium orchid 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Just need 2 more. 2 more. Magenta. Where's magenta again? Hot pink is different enough. Hot pink. Teal. Cool. And just for good measure, lime. Okay. Now those are the colors for season and seasons, all spreads, all scores. Weeks is equal to that for week and weeks. Spread scores equals get data of season, week. For spread and spreads, all spreads dot append spread. Okay, and actually this I'm just gonna want to save as a data frame. Cool, so we can do that. So all spreads, all scores. Week. Okay, so now we just have to think of how we can do this as a data set. So I'm gonna sit down. Oh, cool, I got a comment. Oh wait, no I didn't. That's from YouTube. Thanks YouTube for commenting. Okay. Crank. Okay, now I want to make this plot. I'm making this plot. Before I actually make the plot, I want to save this as a data frame so I don't need to go through and have to run this every time and have it take forever. So for a week, we have spreads and scores. Spreads, scores. Looks like that. So let's turn this off for now and see what this spreads and scores look like. Spreads and scores. get data. So spread scores equals get data. Okay. Let's turn all those off and mess around with it in here. From analysis to import get data. Get data. Okay, and then we'll see what it looks like. So for just 1 week, it takes quite a long time. 1, 2, 3, 4, 5, 6, 7. About halfway through. Come on. Check this if anybody viewed. Yes, there was a viewer at one point. Wow, that's exciting. Wow. No, there wasn't. 3 views. Cool. Not bad. Alright, so what the hell is taking so long? Alright, so it's an array. Minus 2.5 minus 1.5 is the first thing. Yeah, so let's write a new function. Write spread data frame is equal to 1. So get data 2 spread diff. Alright, so what does get data 2 look like? Get data 2 weeks to go back, so spread diff spread I guess we could just look at the difference, but why would you want to? df equals, oh man, what a headache. Okay, so we want, yeah, we may as well just make that a column. Get previous spread performances, team week, season, and weeks to go back data. Get past data. Get data 2. Okay, now save all spread data to write function to save all spread data to a single write function to save all spread data to a single data frame. And that is highest priority. Define write spread data to data frame. Write spread data to CSV. Writes all spread data into a CSV to save time. when calling the data for analysis. Okay. So basically it should be the same thing as get data to or get previous spread performances, get data. Should be the same thing as get data, except we're saving each spread. So the same thing as get data, except we're saving each item. pd.readExcel data.xlsx. Is it all in here? Oh, I put it all in one giant Excel. Oh, interesting. I guess I forgot I did that. So that's not the most efficient way to do it. Write spread data to CSV. You know what? We could just edit get data. Get data, get data, get data, get data, year, week, and then year, week, and then get data, year, week. So that's the spread swing for that game. Prev spread diff, past performance, perf equals get performance against spread, team, week to look for, year. So what are the categories? Let's write out the categories we want. Table columns, basically. Let's just write it in here. So table columns for the spread data set. Oh, really for the spread data set. Alright, so here are the columns. First one is home team performance against spread, previous game. Home team performance against spread, 2 games ago. Home. So we basically want the home team's performance against spread in the previous game, the away team's performance against spread in the previous game, and then we want the performance against the spread in this game. Home teams PAS in previous game, away teams PAS in previous game. XPAS, this game. Yeah, that seems pretty straightforward. And using that, I think we can use this data to get a to build a what's that called, a neural network that updates it each time? I don't know, a neural network that updates with each, that build a state machine, I think. I don't know, I'll just say build a neural network, build an NN that updates with every week. Okay, and that's my main thing I want to do next. In progress, I don't know, this was changed priority to low. Take off medium. Troubleshoot analysis by classifier, I still have to do that. If output, that I'm gonna say is high priority, cool. If output from code is different from PowerPoint, then fix it. Yeah, I'm process of that. Write function to save all spread data to a single data frame. Get new data by data. Organize everything into a Jupyter notebook. Also medium priority. Okay, cool. Well, that's all the work for this morning. I might do a live stream later tonight, or I might just wait till tomorrow to do one. The next thing on my docket is this: write a function to save all spread data to a single data frame. And then the other thing I have to do is figure out what's up with analysis 1. Thanks for watching. Hope you have a nice day.